Well, the nice thing about what we're moving into is we just finished chapter 6. So we're here with vectors in space. So it's very similar to what we did in chapter 6, but we are in chapter 10. And we are on 10.2. Our essential question is, can you find the component form, unit vectors, and dot products of vectors in space? So the magnitude is very similar to what we had, except now the magnitude is the square root of u sub 1 squared plus u sub 2 squared plus u sub 3 squared, where u is equal to, and this is a component form, of u sub 1, u sub 2, u sub 3. A unit vector, remember we take the point and we put it over the magnitude, and the magnitude cannot equal, or the point cannot equal 0, but nor can the magnitude. All right, the sum of u and v, we're just adding them. So it's very similar to what we've seen before. We're just adding, meant to do a highlight there. We're just adding u sub 1 plus v sub 1, u sub 2 plus v sub 2, u sub 3 plus v sub 3. And scalar multiplication is not going to change as well. Notice when I multiply c through to u, I get c times u sub 1, c times u sub 2, c times u sub 3. And the last thing that we're going to look at is the dot product. Remember, the dot product is when we multiply, but we are multiplying and adding all 3 now of these points in component form. So the first question says, find the component form and the magnitude of vector v. So the first thing we have to remember is we are taking terminal minus initial. So for the first one, we're going to take 3 minus 2, and that gives us 1. Then we have 5 minus 4, and that gives us 1. And then we have 2 minus 1, and that gives us 1. Well, that's an interesting component form. All right, now we just have to go ahead and find the magnitude. So if I find the magnitude, I am just taking the square root of 1 squared plus 1 squared plus 1 squared, which is going to give me the square root of 3. All right, the next question says, then find a unit vector in the direction of v. Well, remember the unit vector, we are taking the component form and we are putting it over the magnitude, component form over magnitude, component form over magnitude. Now, at the end of chapter 6, I told you guys you didn't have to rationalize anymore. So I will take this, or if you want the rationalized form of this, I will also take the square root of 3 over 3, the square root of 3 over 3, and the square root of 3 over 3. Either one. All right, we're going to be looking for the dot product. I'm trying to get rid of these. There we go. I can throw them in the air. All right, let's get rid of the let's find the dot product. The dot product of negative 1, 3, and 5, 0, 4, and 2. Do we remember how to do this? Let's do it. We are going to take negative 1 times 0, and we are going to add it to 3 times 4, add it to 5 times negative 2. And let's see what we get here. We get 0, 12, negative 10. It looks like the dot product is 2. Moving on to more things we know. Find the angle between u, which is 4, negative 1, 3, and v, which is 0, 1, 5. Do we remember how to do this one? So we are going to first find the dot product. So let's write the dot product here. 4 times 0 plus negative 1 times 1 plus 3 times 5, and it looks like we get negative 1 plus 15, which is 14. We also need to find the magnitude of each, so I'm going to find the magnitude of u up here. we're going to take 4 squared plus negative 1 squared plus 3 squared. And it looks like that magnitude is 16, 1 is 17, and 9 is 26. So I'm going to write that down here. The magnitude of u is the square root of 26. And v, the magnitude of v, we'll write over here. I have the square root of 0 squared, 1 squared, 5 squared. Hey, I think that's the square root of 26 as well. So let's remember how to find the angle between two vectors. The angle between two vectors, we are taking the cosine of theta is equal to the dot product, which I know is 14, over the square root of 26 times the square root of 26. And remember, to put this in our calculator, we need to take the inverse. So we're going to show it as the inverse. So let's take a minute to do that. And when I find the inverse, the cosine inverse, arc cosine of 14 over root 26 times root 26, I do get an angle of 57.4 degrees. All right, let's move on to one more concept here. It says vector W has an initial point of 3, 0, negative 1, and a terminal point of 2, 1, and 4. So let's first start off by finding the component form there. The component form, remember, is terminal minus initial, so that's negative 1. 1 minus 0 is 1. 4 minus negative 1 is 5. So that would be the component form. Which of the following vectors is parallel? Well, they would have to be parallel if they were the same line just moved. So kind of think about slope, okay? So if they have a drawing in your book, I'll just draw it right over here. If they had a Cartesian coordinate system and they had u here, v here, w, that was not drawn very well, w here, they all would be parallel because they're parallel lines, first of all, but they also, like, let's say that in the drawing it says u equals 2 times v. Well, we know that it's the exact same thing, just multiplied by 2. So let's look at the first one. Can this multiply by anything, scalar multiplication, to get to that? No. So this is not parallel. But if we look at the next one, if I multiply 6 and negative 6 and negative 30 by something, I would get, or actually I guess we would go the other way. If I multiplied this by something, I would get to here. So I know that v is equal to negative 6 times w, therefore it is parallel.